Can you hear me, Zaid?
Yeah,
Okay. So,
yeah.
Assalamu alaikum. Ramzan Mubarak to you.
Walaikum salam. Yeah, Ramadan didn't start yet.
Yeah. Okay.
Ramadan Mubarak for you, I guess, in your
Yeah.
part of the world.
Fine. Thank you. Here is our first Sahri in India. Okay. So, in previous class, we had seen Unit 3. Okay, Unit 3, that was sampling and surveys. In that sampling and surveys, we had studied one important sampling, that was convenience sampling. Convenience sampling, and we had seen in the convenience sampling that there was some biasness in the sampling,
Mhm.
and I think the other was just revise what we had seen.
So how was the test? So how did I do on my test?
Yes, I have not evaluated your test right now till now. I want to give you the second test also, and I'm preparing the second test paper. I'm on it.
Okay,
Correct. So I'll check by next week and forward the result to you. You
all
have
right,
done. I've
got it.
seen it. I have gone over overview of it. It was good. It was. It seemed that it was very easy, and you have done very well in the test. Yes.
Yeah.
Yeah, I know you have done very well. I have taken an overview of the test, not checked, evaluated right till now. I wanted
Did
to
you
give you
see
one
it?
good
Huh?
test. Yeah.
Did you see it though? Did it look like it made sense?
Yeah.
Okay.
Okay. So we were on the sampling. I'm preparing your test two based on chapter two. As soon as it's prepared,
Mm-hmm.
I'll forward you. Okay.
Mm-hmm. You guys fasting right now?
Yeah.
You?
Can you repeat? What were you asking?
Are you fasting?
Yeah, yeah. The fast has just started here in India. I've just prayed Fajr and come to take your class.
Oh, my
I'm fasting.
fasting didn't start yet.
Your fasting has not started yet?
Not tomorrow.
Oh, yeah, yeah. Your fast will start tomorrow. Correct. I have just prayed the Fajr, eaten the Sahari, and just prayed the Fajr and to come here to take your class. Just first,
Yep.
of course, brother. Yeah. We'll start. Here it is. Okay. Okay. So in that sampling and surveys, we have seen first of all population, census, and sample. What was population? Population was the entire group that was under study. Census
Mm-hmm.
was the data about every individual that we collect from the population. Correct? And the sample is a subset of a population from which we collect data. Okay, so
Mm-hmm.
we have seen the differentiation between population, sample, and census. Then it is known as sample survey. A sample survey is a study that collects sample survey. Means what? A sample survey is a study that collects data from a sample to learn about the population from which the sample was selected. Means what? We are surveying the sample. Means from a population. I've explained it. From a population, whole population, we are studying the sample. Study of sample. Study of sample to select it from the population. Select select it to select it
Mm-hmm.
from the population is known as sample survey. Survey means to do some task, and the task of selecting a sample is a study that collects data from a sample to learn about the population from which the sample was selected. Okay, by our definition, the individual in a sample service can be people, animals. Yes, we have gone through all this. Okay, We have seen
Mm-hmm.
this example also, and how to sample badly. Convenience sampling. We have seen convenience sampling selects individual from the population who are easy to reach. Yes or no? Convenience sampling we have
Mm-hmm.
seen. The people who are very easy to reach, we generally select those people. Likewise, I have told you in the library, we will take the first 30 people coming in the library. It is based on our convenience because we are easy. It is easy to record the first 30 students that are coming in a library because we cannot wait the whole day and collect data of every individual and then take out all the attributes of them. Then there is a biasness. Bias means the design of a statistical study shows bias if it is very likely to be underestimated or very likely to be overestimated. Means biasness means what? The output. Biasness is generally bias or biasness. Biasness. It is generally an output, generally an output either overestimated means we have overestimated some result, overestimated or
Mm-hmm.
underestimated. Yes, or
Yeah.
underestimated means for suppose we say that this movie, or you may say that this thing is very underrated or overrated. In that sense, when we judge something below its average or above its average, when there is suppose that the average time spent by the students in the library is 30, or we estimate or took out to be it was 15, so it is very underestimated as it is very far away from the average mean. And if we predict
Mm-hmm.
that it was around 50, so it is over. This is over and this is underestimated. So this both can affect our results if we are biasness towards our data. So I've told you that the data is very important. So the next sampling is voluntary response sampling. We have seen this also, I think. Voluntary response sampling is a sampling in which voluntary response is taken from the individual. Likewise, I've given an example that we make an announcement in the library that there will be a what you say there will be a data collection about the average time spent by the students, and there were 300 students, and only 100 students raised their hands up for giving for giving the response for average time spent by them. So this is what you'll say voluntary response sampling. That I'll list it here. Voluntary response sampling. First was convenience, and we have seen convenience sampling. The based on the convenience, I'll write here convenience sample based on the convenience of the observer or the collector, observer or the collector, data collector who's collecting the data. Next was
Yeah. Okay.
voluntary response sampling. Yes, voluntary response sampling.
Mm-hmm.
So what it was, voluntary response sampling allows people to choose to be in a sample or to by sample by responding to a general invitation. Invited,
Mm-hmm.
there is a choice to the people. I'll write it here. There is a choice to the people to be the part of the data or not. This type of sampling is known as voluntary response sampling. I write in the bracket they accept or reject the proposed the proposed invitation invitation. This is
Mm-hmm.
known as voluntary response sampling. Now the next sampling that we'll be looking in. Okay, So we read this because voluntary response sampling typically gives a sample that is unrepresentative of the population. We want to know about the bias that results is called voluntary response sampling. Most internet polls, yes, we have seen texting and all that. Okay, we have seen this example also, right? Yes, do you remember?
Mm-hmm.
Yeah. So how to sample well? This all were bad sampling. Yes or no? This all topics
Mm-hmm.
that we have studied till here was under bad sampling, which include biases. The first bad sampling was convenience. Remember this convenience. They can ask you in the MCQ convenience, and the second was voluntary response. Voluntary response. Now we are going to see the sampling methods of good sampling or how to sample well. Good sampling or how to sample the data well. How to sample well. Okay. So the first is in the textbook. It is random sampling. Random sampling. Okay, just a minute. I'll plug in the PC.
Yep.
Okay, the first one is random random sampling.
Mm-hmm.
What
Random
does random
sampling.
mean? Yes, sir. What does random mean?
It's not, it's randomly generated from a device.
Correct, correct. Randomly or randomly generated in simple sense we can write randomly generated data or randomly selecting or randomly selecting the individuals from the population from the population is known as random sampling. Random sampling. Okay, so we'll read it about it. It is a very, what you'll say, important sampling method, as different softwares for generating data use the random sampling. There is a library also in Python, random. Okay, so most of the scientists also, when they want the random data, they generally use random sampling method. In convenience sampling, the researchers choose easy to reach members of the population. In voluntary response sampling, people decide whether to join the sample. Okay, both sampling methods suffered from biasness. Therefore, they were known as bad sampling. Yes or no, Zaid?
Mm-hmm.
So suffered from bias due to personal choice. As you discovered in the Federalist Papers activity, a good way to avoid bias is to let chance choose the sample. Means random means based on the chances, based on the probability. Random is all about the probability, based on the probability of the individual, probability of occurring of an individual, of occurring of an individual, occurring of an individual. Okay, so it is like that, individual. So the that's the idea of random sampling. So random sampling involves using a chance process to determine which member of a population are included in the sample. So random sampling involves a chance process. I'll write it here. Random sampling sampling involves a chance process, involves a chance, what he has given, chance process. I'll explain you this, what is mean by chance process to determine determine which members of a population which members of a population, which members of a population are included in a sample, are included in a sample, are included in a sample. For suppose, I'll give you an example. There are 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 1, 2, 3, 4, 5. 5 red balls, 2 blue balls, 2 green balls, and 1 white ball. Okay, so I have to. The question is, this is it. Okay, I have to pick. I have to pick 3 balls, one after the other, one after the other, without keeping the ball again, without keeping the ball again, without keeping the ball again. Okay, without keeping the ball again means what it means that if I have picked a red ball in the first chance, then there are only 9 balls. Then there will be only 9 balls left. Okay, so Zaid, which
Mm.
color ball will have the most chances to be get picked? Chance, where chance comes, there probability comes. There probability comes into picture. Probability, and we are studying statistics. Probability is very important for us because every statistical computation requires probability. So come on, which color ball has the maximum chances to be get picked? Suppose these balls are in a bag. These balls are in a bag, and we have to choose one from this bag. Which color ball has maximum chances? Zaid?
The red one.
Yes, the red one has the maximum chances. Red,
Mm.
one red ball. Just a red ball has the maximum chances to be get picked. Okay. First, red ball has a maximum chance, and can you tell me what's the probability of the red ball to be picked? So, what is the formula for probability? It is the favorable outcomes upon the total outcome. So, how many red balls are there? One, two, three, four, five. So, there are 5 outputs of the red.
50%.
Yes, 50%. Very good. Yes, it is 50%. Correct. Correct. Yes. That's the thing. It's 50%. Correct. So then, what? Who next? Who has the maximum chance after red to be get picked?
Uh, green.
Blue and green have the
Green or
equal.
blue.
Blue and green have the equal chances. Have the equal chances to be get picked. To be get picked up. Yes or no? So what is the probability of blue
Mhm.
and green? So it is 2/10, which is about 20%. Correct, say?
Yeah.
And
Yeah.
same as will be the probability of green. For suppose it is green and this is blue. So both the balls have 20% chances, and there is only then the white ball has the least chance, has the least chance to be get picked up, to be get picked up. So what it is, 1/10, that's 10%. But it can happen that while selecting the balls, it happened that the first ball that selected it's white because we are doing a random sampling. Random, it has 10% chance, it has very less chance, but in random sampling, that's only the main case that we select the things randomly. It can happen in 10. I have repeated the experiment 10 times. So in 9 times, it worked according to our probability. But in the 10th time, it happened that the first ball that I picked was white. It can happen because it is all about chances. Chances, there is a probability, means there are chances If there are chances, if there are chances, then we cannot say. Then the white ball, can happen that the white ball will come first in all the 10 experiments, in all the 10 experiments that we have performed on our bag. It can happen that in a first experiment we picked up white ball first, in the second, in the third, in the fourth. It can happen because it has chances of success. This probability shows chances of success, and its chances of success is very less. But in random sampling, it has occurred 10 to 10 times. And what is our chances of failure? It is 90%, because leaving white, there is 90% probability of other balls also. Yes or no, Zaid? Do you know chances of
Mhm.
success and chances of failure?
Yeah, chances of failure. Yeah,
Yes. So
chances of success is 90 and chances of failure is
this
uh,
10% is chances of success, as its probability is 10%. But chances of failure is
yeah,
90%. This is chances of failure.
yeah.
Yeah, failure.
Because if only the white ones getting selected, then yeah,
Correct, correct,
most likely you're gonna fail.
correct, correct. Yes. So that's the thing. Okay. So I have explained you, I think, given you the whole what you'll say working of random sampling. So come on. For example, to choose a random sample of 6 students from a class of 30, start by writing each of the 30 names on a separate slip of paper. Make sure the slips are at the same size, then put the slips in a hat. Mix them well and pull out
Yeah.
slips one at a time until you have identified 6 different students. An alternative approach would be to give each member of the population a distinct number and to use the hat method with these numbers instead of people's name. Note that this version would work just as well as if the population consisted of animal or things. The resulting sample is called as simple random sample. This method of selecting the individual, I will one more write the definition of the random sample. Selecting the individuals randomly, okay, is known as random sampling. What he has written, random sampling. No? Simple random sampling is known as simple random sampling. Then this random sampling involves 2 methods. Simple random sampling. Then this method. See what I have written here. Keeping the ball again. Uh, I have to pick 3 balls one after the other without keeping the ball again. With what I can do that for suppose I have 3 balls. Okay, one, two, three. Red, blue, and green. In the first chance, what I have picked, for suppose I have picked the red ball. Now, if I have not put back the ball again, how many balls are left in the bag? Zay?
If we don't put the red bag, if we don't put the marble bag, it will be 9, right?
Yeah, but in this, yes, in the previous example, it will be 9. For suppose in this bag, I have made one more experiment. In this bag, there are 3 balls, red, blue, and green. Only three
Oh,
balls.
then 2.
It will be 2, correct?
Mm-hmm.
If I had not put the red ball again, which I have picked in the first chance, and in the second chance, for suppose there were only 2 blue and green, so I've picked the green ball. Okay, so how many balls will be left in the bag?
1.
1. So what is the probability in the third chance? What is the probability that the red ball will be picked? It will be 0, correct?
Mm-hmm.
In the third attempt, the probability that the red ball will be picked will be 0, because the red ball has been picked earlier only. Okay, and
Mm-hmm.
which ball will be picked? Surely it will be the blue ball. So this is known as without what you will say, without replacement. This is known as without replacement of the individual. We have not replaced the individuals. We have just selected the individuals and didn't put it back into the population. Yes or no? We kept them aside. See, we have selected this individual, we have kept it aside. We have selected this individual, we have kept it aside. Then we have selected the last. These are the
Yeah.
types of random sampling. So we'll see it in next minute. So this is known as simple random sample. A simple random sample of size n is chosen in such a way that every group of n individuals in the population has equal chances to be selected as a sample. So what do we do? Oh, sorry. Simple random sample. So what is telling that in random sampling, there is a method that's simple random sampling. Simple random sampling. So in this method, each individual must have an equal chance, an equal chance to be get selected. To be get selected. Okay, it is like that. To be get selected. So for suppose we were looking into a bag where there were 5 red, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there were 5 red, 2 green, 2 blue, and 1 white. So we'll not look to the group of red. In this simple random sampling, we will not look into the group of red ball, but we will look onto single individual. How much chance is there of selecting a red ball, this ball, for suppose this is R1. We'll make them distinct, R2, R3, R4, R5, G1, G2, B1, B2, and W1 for suppose. So what is the chances of this R1 to be get selected is 1 by 10. Yes or no? 10%.
Mhm.
This has
Yeah.
10%. This also has 10%. This also has 10%. This also has 10%. Correct? This also has
Yeah.
10%. The G1, the G2 also has 10. The B2 one also has 10. The B2 also has 10. And the W1 has also has 10. So see, you can see that every ball has equal probability, or you can, if we are saying in chances, has equal chances. Yes or no? Right? Has
Yeah.
equal chances. So this type of selecting is known as simple random sampling, where every individual of the sample has equal chances to be get selected. Is it clear?
Mm-hmm.
Yeah, I think so. Yeah. Okay. So an SRS gives every possible sample of the desired size an equal chance to be chosen. He has telling that if there are n individuals, if there are n, we have taken 10 individuals. Okay. So if there are n, means 1, 2, 3, 4, 5, dot n. So every individual will have a chance of 1 by n. Yes or no? This will have 1 by n, 1 by n, 1 by n. Yes or no, Zaid?
Yeah.
Chances 1 by n. See now here what we were doing. This one upon total number. 1 upon total number. 1 upon total number. So every member of this population will have equal chances. This is the main what you'll say funda about the simple random sample. So SRS gives every possible sample of the desired size and equal chance to be chosen. Picture drawing 20 slips of paper from a hat containing 200 identical slips, and any set of 20 slips has the same chance as any other set of 20 to be chosen. This also means that each individual has the same chance to be chosen in an SRS. However, giving each individual the same chance to be selected is not enough to guarantee that the sample is an SRS. So it is not what you will say fitted in the definition that every individual, if for suppose if there is a equal chance of every individual to get selected, it doesn't the we can it doesn't imply that it is a simple random sampling. Some other random sampling methods give each member of the population an equal chance to be selected, but not each possible sample. We'll look at some of these methods later. How to choose a simple random sample? The hat method won't work well if the population is large. Yes or no? If there are 1,000
Mm-hmm.
students or 100 or 10,000 students, will the hat method work correctly? Will there be an equal chance for all the students to be get selected? No,
No.
because it may happen that the 900 slips may be below, very down into the hat. So putting the hand deep into that hat for an individual, it doesn't seems possible for everyone. So it doesn't have very correct SRS for a large sample. So how to choose an SRS with technology? Label. Give each individual in the population a distinct numerical label from 1 to n, when n is the number of individuals in the population. Randomize. Use a random number generator to obtain n different integers from 1 to n, where n is the sample size. Correct? select. Choose the individual that correspond to the random selected integers. For suppose what he is telling, for a better random sampling, I have a hat. Okay. For suppose I have a hat and I don't have any other methods, and there are for suppose thousand slips. So what I'll do, either putting the hand inside it, what I'll do, I'll write the numbers on the slips. For suppose there are 1,000 individuals, I'll write a number on the slips, 1,000. Okay. Then I'll do use a randomize. What I'll do, randomize it. Randomize it means I'll design
Mm-hmm.
something that it chooses random integers. Not from this, but I'll design something that I'll choose random integers. For suppose that I have chosen integer 300, so I'll look where 300 slip is there in this and remove this 300. Then random comes to be 2, then I'll choose 2 and take it out. If the random comes 980, then I'll choose 980 from here and put it out. So selecting this, choosing random integers is the main method in SRS. Is it clear? Randomize?
Yeah.
Yes. So when choosing SRS, we sample without replacement. Okay. That is, once an individual is selected for a sample, that individual cannot be selected again. Many random number generators sample with replacement. So it is important to explain that repeated numbers should be ignored when using technology to select an SRS. So I have told you that there are two methods of sampling. In sampling, there are two methods: with replacement and without replacement.
Mm-hmm.
With replacement and without. So what it is? Okay. So sampling without replacement. So remember this. I'll copy this onto our thing, that this is important. It is important in here. In SRS, what is the preferred method in? So why I have taken it here, because here he has given some.
Sampling without replacement.
Yes, without replacement in SRS. Simple random sampling. Simple random sampling. So for suppose in the previous means in the starting of the class, I have explained you what is with replacement and without replacement. Yes or no?
Yep.
Yeah, replacement means I have replaced that specific. For suppose I have a bag in that. Okay. Balls. Again, I'll explain you: red. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So what it is, for suppose I've selected a red ball. So what I can do, once I've selected a red ball, and for suppose I am collecting a sample here in this box. So I have put it the red ball. For suppose my first is red ball. So what I can do, I know that my first ball is red. Correct? First ball is red. So what I can do is that I will not put this ball again in this bag. Why? Because I want to perform without replacement.
Replacement.
Without replacement. And if I put this back ball again, it is known as with replacement. I'm replacing again and again and again. Did you get that, Zaid?
Mm-hmm.
When sampling without replacement, an individual from a population can be selected only once. Only once. That was, I am telling that it is R1, R1, R2, R3, R4, R5, B1, B2, G1, G2, W1. For suppose I have selected R1. So in the first case, I have selected R1. Okay. So I will not, this possibility of R1 to be coming has been finished after first pickup, after it was picked, not first, after it was picked. Once means what? As I have picked the R1, then its chances of coming, chances of coming again has been finished or is zero after it was picked. I'll write it in clear. Once the individual is selected, I'll write it in without replacement. Okay, without replacement, without replacement. So in this method, in this method, once the individual is selected, individual is selected, then its chances of occurring again in probability, chances of occurring again is zero. And whose chances is zero in probability, whose chances is zero, you can search it on the Google. It is known as, it is then it is it is an impossible event. Impossible event means coming that
Then,
R1
yeah,
again is an impossible task. Yes or no, say?
it
Who's
can
possible?
never happen again if it's already
Correct.
selected.
Correct. Yeah. Yes, that's it. Then we'll write with replacement. With replacement. Okay. So in with replacement, when sampling with replacement, an individual from the population can be selected more than once. So in this method, the individual after after selection is replaced back into the population again, into the population. It means that after getting selected, after getting picked, it has the same chances, it has the same chances of getting picked again. Is it clear with replacement and without replacement? This was very good.
Yeah.
Okay. So we'll see one sum. So here see, he has given you a technology corner, choosing an SRS, your software OS, randint, same command. Randint means random integer, and he has given randint from he has given the range 1 to 1750. So for in first he has selected 139, in the second he has selected 1 to 1126, in then 920, then 1089. This is the thing. Okay, you can use it
Mhm.
likewise. Yeah. So how to choose an SRS using table D. So for suppose this is a D table. This is table D, random digits. Okay. So there are various lines in the D table. Okay. So just you have to choose some of them. So you can think of this table as a result of someone putting the digits 0 to 9 in a hat, mixing, drawing one, replacing it. So mixing again, drawing another, and so on. The digits have been arranged in groups of 5 with the numbered rows to make the table easier to read. The groups and rows have no special meaning. Table D means this table of arrangement of numbers. It doesn't have some special meaning or special relation with the statistical tool or statistics. It is generally arranged in some random order. It's generally arranged in a
Mhm.
random order. Just in a random order. I'll take this onto our board. Namaste. Okay. So you can think of this table as a result. So we have read it. So how to choose an SRS using table D. So label, give each number you have seen, then randomize. Read consecutive groups of digit of the appropriate length from left to right across a line in the table D. Ignore any group of digit that wasn't used as a label. For the duplicates, a label already in the sample. Stop when you have chosen n different labels. So label, give each member of the population a distinct numerical label with the same number of digits. Use as a few digits as possible. Okay. So then you have to just select it with when there is unselect. Choose the individual that correspond to the randomly selected label. So what generally you have to do that depending on the label, just you have to select the individuals. You got clear how to select an SRSI?
Mhm.
Yeah, okay. So it is an attendance order choosing an SRS with table D. So you're likely to be an 100 possible labels. Okay, each year the State Department of Education randomly selects three schools from each district and conducts a detailed audit of their attendance record. Described how to use a table of random digits to select an SRS of three schools from this list of 19 schools. So what we'll do, see, he has given them. Label the schools from 1 to 19 in the alphabetical order. Move along a line of random digits from left to right. Here, from left to right. We'll move on. From left, we'll move on to the right. From left to right, we'll move in the table for selecting the random digits. Okay. So alphabetical order, move along a line of random digits from left to right, reading two-digit numbers until three different numbers from 1 to 19 have been selected. Ignoring repeated numbers and the numbers 20 to 99 or 00, audit the three school that corresponding with the numbers selected. So what generally we have to do, we have to give an label, six-digit label to some schools. For suppose for a school one, uh, for school one, what we have to do is see what he has told that label the schools from 1 to 19 in alphabetical order. Move along a line of random digits from left to right, reading two-digit numbers until three different numbers from 1 to 19 have been selected, ignoring the repeated numbers and the numbers 20 to 19. Audit the three schools that correspond with the number selected. For suppose we have given numbers to the school, and for suppose we have given what you will say this random numbers to the school. So for suppose I have repeated 19, then 7707, then 21 2. So this is the number 190702. So we will label the schools in this, which row represent which school, and we'll see this number where it is. So then we'll select that school. Is it clear, Zain?
Mhm.
Yeah. So this was remember to include all three steps: label, randomize, and select. Okay. So it is B. Use the random digits here to choose the sample. So you can use these random digits to choose the sample. So 62 skip, 08 select, 16 select, 48 skip, 16 repeat, 87 skip. So that's the thing that we have numbered the things that it is 62, then 08 and 1. 62 it skips, 08 is select, then 16 is again select, 48 is outside our what you'll say outside our numbering, so we will skip. 16 will select, 87 again skip, 37 again skip, then 40 again skip, 95 again skip. Likewise this, see, 17 will select. So this is the thing how we have to move. Did you got that, Zaid?
Yep.
Yeah, so another random sampling methods that's stratified and all will start tomorrow. Is it clear? Okay.
Mhm.
We have finished one major sampling methods today, that was random sampling, and we have seen in it simple random sampling, and we have seen two ways of sampling, that was without replacement and with replacement, and then we have also seen the method how to do random sampling by labeling, randomizing, and selecting the object. Is it clear, Zaid?
Mhm.
Yes, we will do one sum based on this tomorrow, inshallah. Same timing,
Yeah.
okay? And yes, tell me.
Yeah. It's a little early. Don't you think we should have more time?
Okay, so we'll take more time. Yes, okay, okay. So we'll take more time. Okay. So, okay. So then we'll start the another method. Okay. Another
Mhm.
random sampling method. So other random sampling method. We'll look onto the example tomorrow. This example, I'll start the another random sampling method. So the first sampling method was a random sampling, and in that random sampling method, it has one more this in random sampling, it has a specific type in random sampling that's known as, I'll write in. alphabets. Strata or known as stratified random sampling. What does strata means? Just we'll Google it. See what does strata means. The strata word has been evolved from strategy. I'll just write it first of all that you'll get a good idea of it. So strata word has been taken out from the word strategy. So in this, what we are going to do, just give you a rough idea about it. In this, what we are going to do is that we'll be just in a random. For suppose likewise we had R1, R2, R3, R4, and then R5. Okay, G1, G2, B1, B2, and W1. Okay, so this bag has some attributes. Attributes means strategy. What I'll do, I'll make four bags in place of one. What I'll do, I'll accumulate all the red in one bag, R3, R4, and R5. Then all the blue in one bag, okay, and all the green in one bag and all the whites in one bag. So what I have done, made a strategy that to club the same color balls. Yes or no? So this is the stratified random sampling, that seeing some strategy in the population, same sample color. So seeing some strategy in the population, we have to group the data. We have to group the data and then select it. Is it clear, Zaid? So then I will select from, I will give, for suppose I have to select three balls. So what I'll do, I'll select one from this, okay, then one from this, R1, B1 for suppose G1, and one from this, so W1. Then I'll make one more another bag and now select three balls from here. For suppose I have selected R1, W1, and G1. This was my three balls. Did you got that, Zaid? How it is done?
Mm-hmm.
Yeah, that's known as stratified random sampling. So we'll look on to this also. What is meant by strata? Strata means stratum. See, stratum, a layer or a series of layers of rock in the ground, or you can know stratification, the arrangement of classification of something into different groups. See, the arrangement of classification of different things into a what he has strata are groups of individuals or population who share characteristics to be associated with the variables being measured in a study. So you have seen that according to which characteristics I have what you say distributed the balls, according to what characteristics, according to their color. Yes or no, Zaid?
Mm-hmm.
Yeah. So this was the thing, that according to the characteristics of them, we generally, what do you say, that stratified, clustered the big population into small samples and then selected. So strata are groups of individuals in a population who share characteristics to be associated with the variables being measured in a study. So stratified random sampling selects a sample by choosing an SRS, simple random sample, from each stratum and
Mm-hmm.
combining the SRS into one overall sample. Is it clear? Stratified?
Yeah.
Yeah. So I think I have to go to college also. So is it okay? So we'll stop here, okay? 6:57 as well.
Okay.
Yeah. So okay, so we'll go into we'll deep dive into this stratified sampling tomorrow, inshallah, at the same time. And on Saturdays and
Mm.
Sundays, on both the weekend, we'll have two classes this weekend. Is it clear, Zaid?
Yeah.
Yeah.
Yeah, that's
So
good.
I'll give you the times. As it is Ramzan and I have college also. So one will be Saturday and Sunday. There is no school, right?
Yeah.
So one class I'll take around just a minute at 11:30 a.m. 11 a.m. or 11:30 a.m. Will it be good for you?
Yeah, that'd be fine.
Okay, that will be fine. Okay, thank you, thank you. Okay. So Zaid, you can leave the class. Okay. Assalamu
Mm-hmm.
alaikum. Allah Hafiz.
Welcome, Salam. Allah Hafiz.
See you all.